All right, let's start with 6-1. So, well, first, the vocab at the beginning, that's from 6-2, the first one. So don't worry about 1 and 2. But 3 is the ratio of the side lengths is scale factor. Obviously, you need to know that. 6-1 was similar polygons.
We don't have it.
Oh, good. I whited it out. Good. I'm smarter than I thought. Okay, so 4, 5, or 6 questions on those. These are similar polygons. So remember, you could have where you set up a scale factor. You could have where you're missing a side. You could have a similarity statement. So we talked about this before, but the difference between a similarity statement and a proportionality. So similarity is the whole thing, like A, B, C, D is similar to E, F, G, H. And the order is important. The statement of proportionality is the individual side lengths, like A, B to E, F equals B, C to F, G equals C, D to G, H equals A, D to E, H. That statement of proportionality. And then if it asks you for which angles are congruent to which angles, then you would do each individual pair of angles. So A to E, in this case they were all right angles, so they're all but angle C to angle G and angle D to angle H. And then obviously there's scale factor. We have to set up your scale factor. Pay attention to the order. If it says A, B, C, D to E, F, G, H, you need it in that order. If it said E, F, G, H to A, B, C, D, then you need it in that order. Okay, and then always reduce your scale factor. So everybody's okay on those? Mm-hmm. Yeah. Okay, then came 6-2. You don't have, right? Yeah, so 6-3 was the first of the 3 ways to prove triangles are similar. Angle, angle, side, and side, side, side. They'll all be looped together. So you'll get questions that are yes or no, and if yes, why? And you'll give those reasons. Or it could say if yes, show the similarity statement, if anything like that. Okay, and then 11 is your cell tower. So that was a proportional statement. You set up a proportion, cross multiply, and solve. There was a lot like that on your quiz, which again we'll go over in a minute. Question on those. Okay, then came 6-4, which was the other 2 similarity statements, which is or similarity theorem, side, and side, angle, side. Remember that if you're giving these as reasons, you have to include similarities. You cannot leave SSS as your reason. It has to be SSS similarity. You can't leave AA, you can't leave SAS. Just the letters are proving. You cannot use just the letters. The letters prove that the triangles are congruent. We are proving they're similar, so you have to include the word similarity. Okay? Don't lose credit on silly things like that. Questions on 12 or 13? Okay, then 6-5 was all your theorems, the theorems with the triangles, which are these. So 14 is not parallel because they're not proportional. 15 is parallel because they were proportional. And then also in 6-5 were your 3 lines, 3 parallel lines, 2 transversals where you've got proportional statements going on there, and your, what am I missing? The angle bisector, where those would be proportional too. And then the chapter test was the last one. So we went up to 10. Right, this is gone, yeah. Number 1.
You're going to post the answers, right?
Yeah. Number 1 is the pair of congruent angles, so P to A, Q to B, R to C. Number 2 is your ratio of the sides, and number 3 is the actual value of X. So also from 2, you could have gotten your scale factor. Like if I took and reduced either of these, I would have gotten 5, 6. That would be your scale factor. That could be a question. Number 4 was not similar. Number 5 is angle similarity. Number 6 is side angle side similarity. Number 7, AB was 16.2 or 16 and 1/5. 18, AB was 24 and, AB was 24 and 9, AB is 78. Lewis. 5. So it said determine whether the triangles are similar, and then state the postulate or theorem that simple that says it. So you had to, first of all, they both have 33, right? So they all have that one angle. This angle's congruent. And then there's 2 triangles happening here. One that's this one. And you can use that they add up to 180 to find that missing angle. And you get 62. Or you could have used this big triangle and used the 33 and the 62. And you get 85. So either angle you found, they should have matched the other one, and then you had 2 angles.
Wait, do we have an early release this Friday?
No. 4, you had to match up your side lengths, right? So smallest here is 20, smallest here is 11. So I could do 20 to 11. Middle, 25 to 15. 25 to 15. Largest, 30 to 18. And then they all had to reduce the same. So these reduced like the second and the third, right? This is 5/3. This is 5/3, but this doesn't reduce, so it doesn't work. It's got to be all 3 sides. Oh, okay. Careful, because they'll probably do that to throw you off. It's got to be all 3 sides.
So is this going to be like on my YouTube channel?
Yeah. Mm-hmm.
You're famous.
Thanks. Any other questions? Okay, all right, so this one starts with the given that the sides are given to you, and there's actually 2 ways to do this. One is use the vertical angles and then 2 pairs of sides, and that's side angle side similarity. The other is all 3 sides. Both are right. So I can say AC over CE equals BC, God bless you, over CD equals AB over DE, and that's the definition of proportions or definition of proportional.
That always your second step.
Not if you could do the vertical angles one first, so it doesn't have to be that way. And you don't, like I said, you can do 2 of these 3 and add in the vertical angles. A, C, B is congruent to D, C, E, and that's vertical angles theorem. And then you only need 2 of those pairs. Or you could have actually put the value of the sides like 5 to 2.5, 6 to 3, and 8 to 4. I would have taken any of that stuff. You just have to show that the proportions are equal to each other. And then triangle ACB is similar to triangle ECD. And again, remember you have to write similarity. So you could do, if I did it that way, side, side, side similarity. Here would be side angle side similarity. Lewis.
To prove 3, can you just say it's converse of the proportionality theorem? Do you know that theorem?
No, if you're proving the triangle similar, there's only 3 ways to do it. Side, 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 side angle, side, and angle, angle.
Does it not work if you say triangle similar instead of different? Actually, no, it's triangle proportionality.
No, that's the one where you have the mid-segment. I mean, not the mid-segment, but a parallel line. Yeah. Okay, then this one had your parallel lines. So again, you have options here. You could do the vertical angles here. I could say to angle ACB is congruent to angle DCE, and that's vertical angles theorem. Remember, it's all, you have to have theorem there. You can't say postulate, you can't say vertical angles. Has to be theorem. Okay, and then I can use the parallel lines with either pair of alternate interior. So angle A could be congruent to angle E, or angle B could be congruent to angle D, and that's alternate interior angles theorem. And if you don't remember the name, you write out 2 parallel lines are crossed by a transversal, alternate interior angles are congruent, okay? So again, you need 2 of those 3. You don't need all 3 of them. And then step 4 would be that the triangles are similar. Good. Angle, angle, similarity. Again, only need 2 of the 4 angles. You don't need, 2 of the 3. You don't. All right, this one gave you that A, B, C, and D, E, F are right angles, and GF is congruent to GC. So if they're right angles, that means that they are both 90. So you can write that this equals 90, and this equals 90, and that's the definition of a right angle.
Wait, can you just say angle B and angle B?
No. No. Because there's no theorem that says all right angles are congruent. Is there? If it's perpendicular lines, we can say they form congruent angles. That's different. These are two separate ones. And then you'd have to say they equal each other. A, B, C, congruent to D, E, F. And that's substitution. So now you have one pair of congruent angles. Yep.
I meant like, would you put like A or B equals 90 and then...
Oh, I'm sorry. Yes, you can use, because they're not shared. Can you use one letter? Yes, you can. And then the other part that they give you is this is now an isosceles triangle. So the base angles theorem tells you angle F, G, F, B would be congruent to angle G, C, F. And that's the base angles theorem. And now you have that they are similar. So triangle A, B, C is similar to triangle D, E, F. Angle similarity. And if two triangles are similar, then their sides are proportional. And that is the definition of similar triangles or similar polygons. Either one works. Lewis.
That seems to me like the same. I can write as many like proofs as we want to prove it.
Yeah, like there could be more than one way to prove something. Is that what you mean? Yeah, sometimes there's choices. All right, this one says that the lines are parallel, so then CD times CA equals CE times CB. So there's actually a couple different ways to do this. One is you can use that the triangles are congruent, so I'd have to prove that these angles are congruent in addition to one other pair being the top and the one that's shared, and say that they're similar, right? So I could say that this is similar. Then I can set up my proportions. CA over CE would equal CB over CD, and that's the definition of similar triangles. And then I can cross multiply, and you could either write cross multiply or simplify. The other way is that these are proportional, remember? So CD to CB would equal CE to CA. That's triangle proportionality theorem, and then you can cross multiply. Both are right. This last proof says DE is the mid-segment of this triangle. So if it's the mid-segment, then it means it cuts it into two congruent parts. This would be this equal this and this to this. So it would be DB equals AD and BE equals EC. And that's the definition of a mid-segment. So then you actually can continue with this, making DB over BA equal to BE over BC as the definition of proportional. And angle B equals angle B, and that's reflexive. So now the triangles are similar, and that's side angle side similarity. You could also, after the given, which is that it's the mid-segment, state that DE is parallel to AC, which is the mid-segment theorem. It says that the mid-segment is half the length of the third side and parallel to it. So then you can say BD over DA, or actually BD over BA equals BE over BC, and that's the triangle proportionality. Theorem. And then you can say the angles are congruent, and then side angle side similarity.